Hi, good morning, guys. All right, we're going to be talking about functions today, and it says we all mean the same. What it's talking about is when you have an equal sign, and if you have an F and X, it means the same. It doesn't matter what, you're still going to be plugging things in. So we're going to watch a short clip, and I'm going to stand back and let you guys watch it. So here it goes. Oh, sorry. Thought it was going to work, but I guess it's not. There it is.
If f of x equals 3x plus 2, what is the value of f of 3? In this exploration, you will become familiar with function notation and learn how to evaluate functions written in function notation. Let's start with some review. Think back to that function machine we talked about the first day of the unit. When we input a 9 into the machine, we got an output of 45. When we input a 6, the output was 30, and when we input a 2, the output was 10. Therefore, we said the output is equal to the input times 5. But we also came up with a function rule for this machine. We said y equals 5x. Let's take a look at a similar machine. This time, when we input a 2, the output is negative 6. When we input a 6, the output is negative 18. And when we input a 9, the output is negative 27. So we could say in this machine, the output is equal to the input times negative 3. And therefore, this machine has a function rule of y equals negative 3x. So let's take another look at these two function rules, y equals 5x and y equals negative 3x. And let's just throw in another function rule, y equals 2x minus 4. When referring to the functions above, it can be confusing to distinguish among them since each begins with y equals. For this reason, functions are often named with the letters f, g, and h. Let's see how this might look. Let's take our first function, y equals 5x. We can replace y with f of x equals 5x. Our second function was y equals negative 3x. Let's rename that function as g of x equals negative 3x. And finally, the last function, y equals 2x minus 4, we can rename that as h of x equals 2x minus 4. Let's fill in the graphic organizer. So this function is f of x equals 9 minus 4x. We can see f of x, we read that as f of x, and f of x is equivalent to y. The letter f is the name of the function, and x is the input variable. Let's talk about a common mistake. This is a big caution. Y equals f of x is read as y equals f of x. F of x does not mean f times x. Although we commonly associate parentheses with multiplication, in function notation those parentheses do not mean multiplication. Again, y equals f of x. F being the name of the function, and x being the input. Let's go back to the core lesson. Any function rule can be written in function notation. Let's go back to this function, y equals 2x minus 4. To rewrite this in function notation, all we do is replace the y with f of x. And now we have f of x equals 2x minus 4. Again, the only thing that changed was y became f of x. Function notation represents a rule that relates the domain of an equation to its range, where x is the domain and f of x is the range. Let's go back to that first function machine. I see that this function machine has 3 ordered pairs, so we can write the set of ordered pairs like this. F, as in the name of the function, is equal to 210, 630, and 945. So what's true about this function is that f of 2 is equal to 10. What that means is that the input of 2 has an output of 10. So what if I ask, what is f of 9 equal to? Well, we have to look at the input of 9, and we see that the output is 45. Therefore, f of 9 is equal to 45. Let's try guided practice. Given the function f of x equals 2x minus 4, what is the value of f of 6? And what is the value of f of negative 3? So this is a little bit more challenging than what we just previously did. I know I have to evaluate the function f of x equals 2x minus 4. The first time I want to evaluate it, it's for f of 6. Well, if I take a look at f of 6 and I compare that to f of x, I notice that x is equal to 6. So each time in my function rule where I see an x, I'm going to replace it with a 6. So f of 6 is equal to 2 times 6 minus 4. Notice that each of the pink x's has been replaced with the number 6. Now, since I want to evaluate this for f of 6, my f of 6 on the left side of the equation will always remain as f of 6. F of 6 is equal to 12 minus 4. All I did there was multiply 2 times 6. And now let's continue simplifying the right side of the equation, and f of 6 is equal to 8. Final answer. Let's do the same now for f of negative 3. Negative 3 is now my x value, so each time I see an x, I'll replace it with negative 3. F of negative 3 equals 2 times negative 3 minus 4. Let's simplify the right side of the equation. 2 times negative 3 is negative 6, so f of negative 3 is equal to negative 6 minus 4. And finally, simplify negative 6 minus 4, we get negative 10. So f of negative 3 is equal to negative 10. I'm going to let you try one on your own now. If g of x is equal to 3x plus 2, what is the value of g of 3? What is the value of g of 0? Just to remind you, g is just another name of a function. Instead of f of x, we can use g of x or even h of x. So don't let the g distract you. It's the same as an f. So what you're going to do now is pause the video, try this one on your own, and when you're ready to check your answer, you can press play.
I'm going to go ahead and let
Are
it
you
run
ready to
so you
check your
can see
answer?
it.
So for g of 3, when we replace both x's with 3, we get g of 3 is equal to 11. For g of 0, when we replace both x's with 0, we get g of 0 is equal to 2. How did you do? Okay. In this exploration, you have seen functions written in function notation and learned how to evaluate functions written in function notation.
This is what your I will is. Okay, what you're going to be doing today is this paper right here. Let me hold it up here so you can see it. All right, you're going to be doing this paper. Okay, it's the same as this right here on the front. You're going to fold it in half because it's a foldable. So it'll be in your notebook just like this. And you're going to be taking notes. Now, you're going to be filling in the notes that goes here. So, here we go. Okay. A function can be through as a machine assigned one output to every input. So, there's the name of your function, just like she was talking about. This tells you what number to plug into the function right here. F of x means the output of the function f when the input is x. We often refer to this as y, just like she was talking to you about. And of course, here's your function right here. Okay, you'll need to write this. Remember, you can pause at any time that you need to. All right, here's your function machine. And you have two functions on the front of your paper that looks like this. And here's the illustrated. If f is 2 and f is negative 1. Here's your function machine, and we're using that equation that we had right here. So, there it is. we put the 2 in, we have this, and when we plug in 2 to here, we're going to get f of 2 equals 10, because that's the output. Now here's the other one. When we put f of negative 1 into here, we get 3 times negative 1 is going to be negative 3. So and when we subtract a negative from a positive, we're going to get a 1, and it's a positive 1. Okay, on this right here, I want you to use these right here onto this one, this one, this one, and this one. Do not do when it comes to f of 2 plus f of g of 1. You can do this as a challenge if you want. But right now, I do not want you to do these, okay, down here at the bottom. I only want you to do 1, 2, 3, and 4. Okay, you're going to do your g. You're going to use that f of 3 right here. And then when it says g, you're going to use it in this equation. So it says f of 3. There's your function for f of 3 right here. And that's the number you're going to plug in. And that's what you're going to do on these two. Okay? All right. Now you're using this. And it's asking you, what is f of 5? And you plug it in, one of these, and see what f of 5 is. Is it A, B, C, or D? Okay, here is another one that you need to do, and you can see which one is it. Okay, here's the challenge. This is where it says, which represents f of x plus 1. Okay, that means we have to put that in here. So this is going to be a challenge. Which one is it? Which one would it be when you're putting in that? Okay. All right, when you get done with your foldable and you've watched the video, you have an exit slip that will need to be turned into the basket, and it looks like this, and it says justify if it's a function or not, and you need to tell me why it's a function with that. Okay? Any questions? Hope not. If you have anything else, if you are done ahead of time, you need to work on your homework.